There's more to networking than just putting devices and cables together. We want to be able to talk about some of the different network design principles. Find out next right here on IT Pro TV.
You're watching IT Pro TV.
All right, that's right. There are many different network design principles for us to take a look at. And here, of course, to help us out is going to be Mr. Anthony Cerqueira. Anthony, welcome to the show. How are you doing?
Doing great, Ronnie. Thank you so much. Let's jump right in
All right.
because we have a lot to talk about. And, you know, one of the things, Ronnie and I have both been teaching Cisco networking technologies and Cisco network design for a really long time. And one of the things that him and I have just taught over and over and over again, I know it like I know my middle name, Joseph. Anyways, it's the three-layer model,
Right.
or you'll often hear this as the classical hierarchical,
Right.
and it took me a long time in my Cisco career to be able to say hierarchical, by the way, but this is the classic model. So we have three layers. We have the access layer, we have the distribution layer, and then we have the core layer. The first thing that I need to warn you about with this model is if you haven't experienced this, you will. Different people love to call the layers different names. Like, Ronnie, do you have a different name for any of those layers, or have you heard a different name for any of them?
I've heard about them, but I can't really remember some of them. But I have heard different ones over, and even the idea of three-tier, I've heard as three-layer model. I've heard it as tier 3 models. You name it, I've actually seen stuff like
Yeah,
that. as well.
multi-layer model.
Right.
Yeah, one of the ones that I've heard a lot for the access layer is the workstation layer. Now you can see why they would call it the workstation layer. The access layer is where people connect to our network. That's why in this diagram, Ronnie and I show you some traditional layer 2 switches and then some wireless access points. So how are you getting people on your network? Well, you're plugging them into switches or they're connecting over the air through an access point. So you can see workstation layer. I actually like that name
Right.
because it makes us think of the people out there on their workstations connecting to the network. Now we move a layer up and it's the distribution layer, often sometimes referred to as the policy layer. And this is where we have routing certainly taking place, but it's also where we do a lot of things like security. Like, hey, wait a minute, can this group of people over here access the internet? Can this group of people over here access this group of people over here? So a lot of security, a lot of quality of service, a lot of policy goes on at the distribution layer. And then we have the core layer. Ronnie, I often hear this is backbone.
Right.
Yeah, the backbone layer. And Ronnie, it seems to me that there's probably one thing that's really important in the core, right? Speed. Yeah, I always used to say it's like real estate, right? Location, location, location in real estate. For us with the core layer, it's speed, speed, and more speed.
Right.
Yeah, because think about it, the core of the network is where there's this aggregation taking place of all of these different systems that want to communicate. You need to have enough bandwidth in that core for all of the different resource access that's taking place. Now, there's something that I want to express to you about this classic tiered hierarchical model, whatever you want to call it. And that is something that I didn't used to teach and that is special to Encore. So I'm glad you're here. This model emphasizes what we call a north to south or south to north type of flow of information. And this is changing. In networks today, we're finding a more east to west. Yeah, a side to side transfer of information. And I'm going to prove that to you in a moment. But just think about that, where this classic model really, when we lay it out, we think of traffic as moving from the south to the north and then from the north to the south. Suddenly, I feel like I'm teaching about the Civil War in American history. But so just be ready to be flexible here on really a paradigm shift.
Yeah, there's no doubt that as we start to see this as well, most of the time people don't realize where is it actually used. So if they start off in a small shop, they might say, Anthony, I don't see a 3-tier model that we've implemented. So why are we talking about it?
Yeah, they're probably in a collapsed core, right?
Right.
Yeah. Look at this. So this is when you hear two-tier or collapsed core, what you're doing is you're simplifying things. Like Ronnie indicated, if we're in a small environment, it doesn't make sense to distinguish the distribution layer from the backbone layer. So under that model, we're going to go ahead and do an access layer that leads right into what we call the collapsed core of the network. Routing's going on in there. The policies going on in there. The QoS is going on in there. In fact, that brings me to a great point. One of the reasons we don't do this in a larger network is, remember we said speed was super important in the core? We don't want a bunch of security going on, a bunch of QoS going on, because that could add overhead. So you take the core and make it all about speed, and you do all that complex policy and security stuff at the distribution layer so that you can keep the core running as fast as humanly possible. In a smaller infrastructure, it's not as critical for you to be like, oh, we can't do QoS at the core, we can't do security at the core. It's just not that critical. In a smaller network infrastructure, the segmentation of those jobs isn't as critical. So we could just mash the distribution and the core together, and oftentimes you'll have a specialized device in your core of the smaller infrastructure that can do it all. It does the QoS, it does the security, it does whatever else you need it to do. We know that's one of the beauties of Cisco devices, is that one device can be a great firewall, a great traffic conditioner, a great router, a great switch, and the list goes on and on of what that one device can do.
So let's talk about that core just for a moment more, the idea of the collapsed core. So sometimes those particular devices that are on the distribution layer and that collapsed core as well can be like a layer 3 switch, right? In which we can actually have both the routing as well as the switching function actually in that. So sometimes we see it, and we always see it diagrammed with multiple devices. But Anthony, in a really small shop, we could literally kind of collapse that even down to a single device, and most people don't realize that.
Such a great point. Think about one of the most famous devices of all time from Cisco. It's the CAT 6500, or the CAT just 6000 series devices, the 6509. Those devices became so incredibly famous, and they're still running in networks today, doing a great job, even though they'll be end of sale and end of life for many, many, many years. That is like all about the collapsed core, as Ronnie indicated. In fact, that device, the 6500 series device from Cisco Systems, that device can do it all. It's a remarkably powerful switch. It's a remarkably powerful router. It's a remarkably powerful firewall. You could get a VPN module and stick it in there, and now it's your VPN device. So boy, oh boy, not only do the layers collapse, but the device itself becomes so incredibly multi-purpose.
All right, now you had talked about the idea of east-west, and you were going to demonstrate something. What are we talking about here, Anthony?
Yeah, we are talking about a two-tier topology in one specific type that's called the spine leaf. Now, you have encountered this if you've been investigating Cisco's application-centric infrastructure, Cisco's ACI solution. So what we're looking at right now, Ronnie, is two simple layers inside a really modernized data center, and we have a spine layer and we have a leaf layer. So the spine layer is our CAT 9000 series. So now we're all the way up to the Cisco 9000 series devices, and these 9000 or 9Ks, as we like to call them, are running the controller intelligence. By the way, this is very much Cisco's implementation of software-defined networking. So with SDN from Cisco and ACI, it's a two-layer model. We have the spine with these fancy 9000 series devices. Then we have a variety of the devices that can operate at the leaf layer. They just have to support ACI. And that's more of like the access layer concept. And it's these two simple layers that really are efficient at this east to west or west to east traffic flow. Notice it's not this big emphasis on north-south or south-north. It's traffic moving from machine to machine. What is this all about, Ronnie? It's about virtualization. Think about it. You're going to have all of these VMs running in this environment that are communicating with each other in that east to west flow. Now, Ronnie, there's something I want to teach everyone on this model, and I started to draw them in, and then this slide got so ugly so fast. But it's, how does the physical connectivity work? Well, here's how it works. It's very simple. Every one of those leaf nodes makes a connection to every single spine node. I'm going to repeat that. It's so critical. Every single leaf node makes a connection to every single spine. You don't need the leaves to directly connect to each other. You don't need the spines to directly connect to each other. What you do is you have every leaf connect to every spine. What this does is it builds in redundancy right away into the design. But here's the thing that it does that's, I think, the most exciting and why it's used for Cisco software-defined networking in ACI. It makes for a predictable latency. You're always that one spine hop away, if you will, from where you're getting your traffic to. Super predictable latency. And Ronnie, if we need to scale it, we can just add another core or spine device and then just make sure all the leaf nodes are connected to that device, and we just immediately scaled it. So every leaf node connects to every spine node, and that's how the physical connectivity works in this really interesting and brand new spine leaf topology.
All right, there's another topic that we need to cover just briefly. Let's talk about the idea, which is a Cisco term here, right? The idea of the fabric capacity planning. That sounds fancy for something. What are we talking about here?
Yeah, I'm so glad this has come up. So this term is being used a lot by Cisco now. It's being thrown around for so many different technologies, and that's fabric. What is Cisco really referring to now when they speak about an enterprise fabric? Well, this is what they mean, Ronnie. They mean that it is easily automated and programmable. So we have inside of a true now Cisco fabric, we have two layers I want you thinking about. When you and I think about wireless and wired, we tend to think of the physical, okay, the physical wireless radio frequencies and the physical gigabit Ethernet that makes up our network. Well, now we're going to call that the underlay. And that's the physical stuff that makes the network work. That's the underlay. And so when we say fabric capacity planning, we're talking about, how much bandwidth do we need in the underlay, the physical network plumbing? The overlay, that is the virtualization layer. So capacity planning does occur for the overlay, the virtualization, but we handle that now with new technologies that really make it a non-issue. Let me give you a quick example. With classic VLAN technology, we could have like 4,096 VLANs, right?
Right.
For the longest time, Ronnie and I would look at that and go, well, that's more than we'll ever need. You know, we need a VLAN for sales. We need a VLAN for marketing. We need a VLAN for these people over there. You didn't need many VLANs. Well, how about cloud? How many VLANs do you think we would need in like in AWS, right?
Who knows?
When you start to really virtualize and take advantage of cloud tech and stuff like that, you suddenly realize we could need tens of thousands of VLANs. And so for scalability in the overlay portion of your fabric, VXLAN was invented. VXLAN supports like 16 million VLAN identifiers. So that problem just went out the window. So just remember, when you're planning for capacity in your fabric, you're most often talking about the classic, how much bandwidth do we need at the underlay, at the physical layer? And one of the things to think about with this is that more so than ever, we are seeing networks require twice as much bandwidth. And maybe that'll happen more than once in the lifetime of the network.
Easily.
Yeah, it's like, oh my gosh, 4 years ago we needed twice the bandwidth, and now we are here 4 years later and we need twice that bandwidth that we needed 4 years ago. One of the reasons for that is the advancement of technology. Look at wireless. It used to be that we could only connect at like a couple of megabits per second, and you were excited about that. Now we're getting close to gigabit per second speeds with wireless. So there's just higher bandwidth connections than ever before being aggregated into key points of our network. So provisioning the underlay of our fabric becomes critical. And how about power over Ethernet, Ronnie? It seems to me more devices than ever would want that.
Yeah, there's no doubt, because it actually gets rid of an additional power source that you'd need supply for those types of things. So we're starting to see where individual devices itself, we need to think about the idea of, if we're doing power over Ethernet, how much the overall bandwidth or power can be supplied by that switch too. So making those important decisions on, is this sufficient power, is actually key as you actually start doing that. So I want to come back to something here, Anthony. So now that you set that up for us, the idea of understanding this fabric capacity. So can we view it something like this, where we talk about, here it is, here's the bandwidth that we need in terms of the underlay, but the virtualization layer, that consumes that particular idea of bandwidth itself. So one seems to be more of a consumer and the other one is a supplier. Does that seem right?
What a great way to describe that, Ronnie. That is so awesome. That's a great way to think of it. And you just brought up the point that this is more complex than ever, isn't it? So you have this virtualized, extremely flexible overlay. So it's no longer all that straightforward about what you need in the underlay. It is no surprise. I almost said underwear. Oh. What you need in the underlay, not underwear. You should probably already know what you need as far as underwear goes. So the great news is that Cisco does give us tools that will help you plan what you're going to need. So there will be like these bandwidth calculators now that are fine-tuned for the new fabric environment, and they'll literally say like, okay, Ronnie, at best guess, how many VMs do you think are going to be, or how many containers are going to be participating in your overlay? And then they'll help you come up with numbers as far as what you're going to need in the underlay. And that would include things like power over Ethernet, as you mentioned. So really cool stuff.
All right. Well, Anthony, I think that kind of wraps up our topic for right now, but there is plenty more for us to actually think about. So in this episode, remember, we covered the idea of the different types of network designs that you're actually going to encounter, such as a 3-tier as well as a collapsed core. And then Anthony introduced that spine leaf type of technology for us. That also we also talked about east-west as well as north-south traffic. Remember, there's a lot of things going on here, so take the time, maybe watch this episode over again if you need to, but that gives us a great place to sign off. So for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your Cisco Encore Show.
Thank you for watching IT Pro TV.